So I'm here today interviewing Lance Pritchard. Lance, welcome. Your major life achievement was improving a critical clamp used in high voltage electrical transmission towers in the 1980s and 90s in Victoria.
The 500 kV line from Moorabool to Portland supplies two of the Commission's important customers, the Alcoa aluminium smelter and the Electricity Trust of South Australia. It's important that we maintain an uninterrupted supply of power to these important customers, which poses a problem when maintenance work needs to be carried out on the line.
500 kV. How much electricity are we talking about?
Well, this is 500,000 volts.
So we're talking about major electrical transmission towers in the southern part of Victoria, the state of Victoria in Australia.
Yes, that's right. I was a senior technical officer in the transmission department. I knew that they were having problems with the line.
On the Portland power line, clamps on the spacers had been working loose. Power Grid Engineering contracted Air Mobile Australia to fix the problem with guidance from United States experts.
And I was told that the clamps holding the actual conductors within each phase were coming loose.
This was the State Electricity Commission, the SEC.
Yes, the SEC. The phase is made up of three conductors, and because of the span, they're held with spacers to keep them in their correct location. Now, the spacer has four legs.
So these are the four legs. 1, 2, 3, 4. These are the legs of the spacer, which is that sort of rectangular device in the centre.
Yes, that's right. And then, of course, there is a clamping onto the conductor. I did a lot of design work for every department I was ever working in.
And what was the actual problem with this high voltage clamp for those towers?
When the clamp was done up, it didn't flex. It was extremely strong and it crushed the conductor.
Can you just help us understand how critical these clamps were in this spacer arrangement for these high voltage wires?
The conductors needed to be held in the square configuration. Otherwise, if they were just flopping all over the place with wind and etc., clamps were coming loose, the clamp was falling apart, farmers were finding bits and pieces in their paddocks. But the main problem is, once the bolt lost its tension and the clamp lost its clamping force, the vibrations of the conductor within the clamp would wear away the conductor.
Is this a very dangerous thing?
Well, yes, extremely. They were worried that if the conductor wore through and, of course, fell to the ground, you start fires. It was even thought that they could pull over a couple of towers. If that was to happen, they would lose power to Alcoa smelters. The aluminium pots would start to solidify after about 3 or 4 hours. And at that stage, we were supplying quite a lot of power to South Australia. It was estimated, worst case scenario, the loss, it could be anything up to $360 million.
In late 80s dollars?
Yes.
Absolute fortune. If you like what you're experiencing right now, do like and subscribe and comment to this channel.
This is the leg of the spacer, and this is the one conductor. Of course, the bundle was made up of 4.
Now, the conductor is the electrical cable. Is that what we're talking about?
Yes, this is the electrical cable. This bolt was coming loose, and the reason it was coming loose, the conductor was being crushed by the clamp, and the clamp was extremely rigid. But the load within the clamp only goes onto a very small points of contact between the clamp and the outside layer of the conductor.
So what did the SEC, the State Electricity Commission, do to try and solve this very serious problem?
They went back to the manufacturer, Dalmyson, that manufactured the spacer with its clamps. If they did know what the problem was, they weren't going to say. The SEC then found out that in Japan they had exactly the same Dalmyson spacer and they were having exactly the same problem, which they hadn't found a solution for. Now, after that, the SEC went to a high voltage transmission line maintenance company.
Usually, pilots stay well clear of power lines. But for some years in the United States, helicopter crews have been servicing live conductors. It avoids costly shutdowns and saves money.
They didn't have any idea for fixing it, but they would like to be involved in any fix if we ever found it. So then the transmission department went to the Herman Research Laboratory in Richmond, and the head scientist there, he was a stress analysis scientist. His first report was that they just hadn't been tightened up properly.
And were you convinced by that report's accuracy and veracity?
No, absolutely not, because I know the way that they would have been tightening these bolts up, and they wouldn't be mucking around. Then I started to do some research of my own, and it was this problem of the clamp being too rigid and was not following the conductor as it relaxed within the clamp.
What happened next?
I was asked, could I prove what I was saying was in fact correct? I said yes. I said, I can design a test rig and get Herman Research Laboratory to actually carry out the test by putting a strain gauge within the bolt. The test rig I designed was applying a 4.5 tonne load to a length of conductor that was about 2.5 metres long. The clamp was tightened up on the piece of conductor, and the strain gauge within the bolt was able to show exactly what was happening within the bolt. It was losing its tension so fast that after around a week it had lost almost 50% of its tension.
So you weren't satisfied with that initial report. So what happened next?
I was asked, well, what can we do to fix it? I determined that the cheapest way was to actually design a special non-standard nut. So it had a very thin wall, but I designed the body of the nut to be slightly longer so that it could stand the strain. We had 135,000 of these nuts manufactured.
What was the sort of distribution of the repair, across the state of Victoria that they needed to handle?
The Portland line. So Geelong to Portland, but there were 135,000 of these to be installed.
Specialist crewmen are equipped with air tools to tighten loose bolts on the spacers to a specific torque and lock nuts to maintain the necessary torque. Sitting outside, the crewmen are harnessed to the chopper frame with a double lanyard. On the opposite side, CO2 bottles, for the air tools, balance the man's weight. With thermal clothing for warmth, crewmen wear special conductive suits for protection from induction, and they carry a metal wand used to bring the chopper to the same potential as the 500 kilovolt power line.
This is where the American maintenance company came in, and they proposed to actually install these nuts with the line still alive, but install them using a helicopter.
Each sortie lasts about 1 hour 20 minutes, in which time 50 spacers can be serviced and the line checked for faults. Meanwhile, the chopper approaches the power line cautiously. The crewman reaches towards the conductor with his wand, drawing a huge spark.
The helicopter is like a capacitor, and it's getting charged up to the same potential as the line. And at 500 kV, that requires a lot of charging current. So therefore, that's why you see the spark when the helicopter is approaching the line.
Has this ever been done before?
Never. The actual blade of the helicopter was passing between the conductors.
It sounds death-defying.
And as the helicopter approached the live line, they would reach out and connect up to the live line.
Once he's bonded to the conductor, the crewman is safe to work on the spacer. It'll take until Christmas to service both circuits on the Portland power line. There are 40,000 spacers, and that's 160,000 bolts and lock nuts. But all being well, the smelter will keep smelting, and Victorian power will keep flowing to the South Australian grid without interruption.
This had never been budgeted for. $6.25 million was suddenly arrived out of the back pocket and provided because of the urgency of if they were to lose this line, it would be a disaster.
So, Lance, was the SEC, the State Electricity Commission, were they grateful for your help?
I suppose they were, but they didn't say it. I never even received a free lunch, but I was asked, was I going to put it in the suggestion scheme? And
so tell us, what does that suggestion scheme mean?
If any employee makes a suggestion and it's approved, they normally get 10% of the savings.
So you were just telling me, Lance, that the net savings of this nut, this lock nut that you developed, would have saved in the order of $350 million?
Yes, thereabouts, yes.
So if you put your contribution to this solution into the suggestion box, you would have been eligible for about $35 million?
Well, theoretically, but I was really mainly interested in I knew the solution was correct, and I was really just mainly interested in getting it carried out, getting the fix completed.
So why didn't you put your technical solution to this very expensive problem into the suggestion box and be living in the Bahamas for the last 20 years?
I thought it was more important to get the fix carried out.
This is the achievement in your life that you're most proud of. Why is that?
When I saw that they had been, the engineers and the scientists that were involved in 3 countries didn't seem to have any suggestion of what the problem was, and now it's all been fixed. So that was great.
But we're also talking about potential bushfires and possibly other harm to life and property. So you could say that you've headed off some very serious consequences if this was not addressed.
Well, yes, that's true.
What a story. Wow. And at the time, you weren't even a qualified engineer.
No.
It's that maverick Aussie spirit. It's just coming out again. It's just unstoppable. Lance, thank you for this life achievement story.
Thanks for being interested.